first derivative of f satisfies the inequality 0 is less than or equal to f prime of x is equal, or is less than or equal to 7. For all x in the closed interval of 0 to 6, select the values of f prime are shown in the table above. The function f has a continuous second derivative for all the numbers. Use the midpoint Riemann sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of f of 6.
So we're using midpoint Riemann sum with 3 subintervals. So let's go ahead and make our loop. Here's loop 1, loop 2, and loop 3. So we're looking at the integral from 0 to 6. And our given table is f prime, so f prime of x dx. So looking at this, if I were to cover everything and only look at one subinterval, what number is in the middle? 3.5. So we have 3.5. And then the difference between 0 and 2 is what? 2. And then let's go ahead and do the next one. What is our middle set on this one? 0.8. And the difference between 2 to 4 is 2. And what's our last middle value? 5.8. And again, our difference looks like it's evenly done, which is kind of nice. So then let's do our mental math. Well, I'll just write it on the side over here. 7 plus 1.6 plus, so 5.8 is going to give us 11.6. And that value is going to be something 0.2. How many 0.2? 20.2. So getting that part is going to give you 1 point. This right here is 1 point. The second part is the part that's kind of difficult in a way, unless you knew to use the fundamental theorem of calculus. And I kind of gave you a heads up on that. And then it says, approximate the value of f of 6. So looking at this, don't we already have f prime of x? Yeah, we do. So I could do f of 6 minus f of 0. So let's put that formula in. We could have integral from 0 to 6. Just going to write out that formula first and kind of redistribute. Dx is equal to f of 6 minus f of 0. And the good thing about the f of 0, if you looked at the beginning, it says f of 0 is equal to 20. So that was given for a good reason. So our goal is to make f of 6 by itself. So using our knowledge of algebra, can I add f of 0 on both sides to make f of 6 by itself? So we have f of 6 is equal to f of 0 plus the integral. I'm not going to read the whole thing. So let's see what I know at this point. Didn't we already find 20.2 for the integral part? 20.2. And they already gave us f of 0 is 20. And that's going to give us our final answer. It is 40.2. And you want to always write this in sentences and try to steal sentence stem from the original question. If you want to write more than you need, it's not going to hurt you, okay? So at some point, if you want to write the midpoint Riemann sum, blah, 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 that's fine. But the amount that's going to be enough is going to be this. The approximation, the approximated value of f of 6 using midpoint Riemann sums is 40.2.
Are we able to abbreviate on
The approximated is like a typical abbreviation you may. Riemann sum you may, IVT you can, MVT you can, okay?
like IROC and AROC?
Yes, IROC and AROC, correct. And then getting this part right here, knowing to use the second or fundamental theorem of calculus is 1 point. And of course, our final answer with the wording. And again, always write more than you need, okay? So let's go on to the next one. Okay, Kara's going to read part B.
Determine whether the actual value of f of 6 could be 70. Explain your reasoning.
And the reason they're saying the actual value is we're going to actually integrate, okay? Because when you integrate, it'll be more specific. So I'm going to borrow this right here, okay? So when I borrow this, we have f of 6. Go get water if you need. F of 0 plus the integral from 0 to 6. This part we're going to actually use calculus. So f prime of x dx. And since we're looking for the actual value of f of 6, let's start by just putting in 20 that we already know. The integral from 0 to 6 of f of 6 dx. So let's go to our graph. On our graph, when you go to x equals 6, what does f prime of 6 say? 7. So I'm going to write on here, again, 0 to 6 of the 7 dx. When I integrate 7, we get 7x, correct? 7x. And we're going to plug in 6 and 0. And I should tag along the 20 all the way. So let's do this part right here. I'm going to do this part on the side. So we have 7 times 6 minus 7 times 0. That's going to give us 40, is it 40 something? 42. So we have 20 plus 42. That's going to be how many? 62. So can it actually reach 70 or no? No. So what I want to do is, again, steal the sentence stem. I'm going to say the actual value of blah is. I guess I could underline this and say could not be. So let's write on here, do I have enough room? The actual value of f of 6 cannot be 70. And you could even write on here because 62 is less than 70. If you want to over explain, okay? So from here, let's see what our point on the parts are going to be. Knowing that at some point you get 42, it's going to be 1 point. And the whole sentence with the sentence stem, and again, write more than you need. So part C and D did not relate to A and B, which is kind of nice, okay? And part D, in my opinion, it'll take a while, but it's the easiest. So what are we looking for on part C? We're doing double prime. So we can use the fundamental theorem again. If single prime is without the primes, double prime must have single prime. Okay, so that's our pattern. So let's write that out. So if I were to use that formula and just kind of add one extra prime, that's going to give us the integral from 2 to 4, f double prime of x dx is equal to f prime of 4 minus f prime of 2. So we had 1 prime, 1 less prime, 2 prime, 1 less of that 2. We all see that pattern, okay? So then the nice thing about this is the fact that we have the value in the table. So go to your table real quick. Find when x equals 4. What is f prime of 4? 1.7. And then 2 is for f prime of 2, right? And that's going to give me negative 0.3. And again, we want to write it in sentence, okay? Typically, if you stop right here, you give full credit. But just in case there could be AP graders that want sentences all the time, over-explain. So I'm going to say the value of the integral from 2 to 4 of f double prime of x dx. And again, just write the word is, negative 0.3. So again, typically when you evaluate, you can stop right, wrong one. You can stop right here, okay? But try to write sentences if you can. At least when they're looking for it, they're not gonna go, I didn't see it, no credit. That will be 1 point, and also, oh, my bad. I did it wrong. This whole row is 1 point, and this part is another point. Okay, the last one is a limit, and it looks like we're reaching a number on the limit. So the first thing that we automatically do when it's reaching a number is we do what? Plug it in. So when you're plugging it in, here's what was really picky last year, okay? Students that had the right limit did not get credit if they did not write out the limit had 0 over 0, okay? So for 0 over 0, they want you to separate it. the first thing I'm gonna do is plug in the upper limit. Limit as x approaches to 0 of, just gonna plug it in, f of 0 minus 20e to the 0. And then that's gonna give us basically, do we have the value of f of 0? Oh, we do, 20. That was given at the beginning. So e to the 0 is 1, so 20 over 20 is how many? 0. And then independently, you need to test out the other limit. On the bottom, we have 0.5 of f of 0 minus 10. And we know our f of 0 at the beginning was given as 20. What is half of 20? 10 minus 10, that is also 0. So you must have this. So if you want to just put a big star on there, please do. Because the limit questions are typically so easy, you want to make sure you get all the credit on that part. So now, when we have 0 over 0, we use L'Hopital's rule. So let's write that abbreviation. In the L'Hopital's rule, as a reminder, you derive the top, independently derive the bottom, and you plug it in. So let's do that. Limit as x approaches to 0. When I derive f of x, that's f prime of x. When I derive e to the x, it is itself times the derivative of the power. This one happens to be 1, so it's simply 20 e to the x. Over, on the bottom, we have 0.5 f prime of x. And do I need to do anything about the minus 10 derivative? Nope. So let's plug it in. Plug in the 0. So we have f prime of 0 minus 20 e to the power of 0. Again, it's quite tedious. 0.5 f prime of 0. Now, go ahead and find f prime of 0 on your table. Just go back and forth. What number? 4. Minus 20, because negative 20 e to the 0. And then we have 0.5 times 4. And that's going to give us some number. Negative 16 over half of 4 is 2. We got to it, negative 8. And again, over-explain. So let's restate the question and say blah is. So let's put the limit as x approaches 0 of this function that I'm not going to read. Is negative 8. And our point system. Testing out our L'Hopital's rule right here, that's going to be 1 point. And then our final answer with the sentence, it's going to be another point. And again, typically on these, you don't really need a sentence, but over-explain, okay? Filling out the whole box is your goal. So then, let's talk about where you can actually stop. Because I told you guys, even at the beginning of the year, when we have free response, as long as you plug it in, you don't have to evaluate anymore, right? So I would stop right here. Then that way, if you make a silly error and you mess up, at least they could say, hey, that was the right work, okay?